Okay. On behalf of the Joint Victorian Chemical Engineering Committee and the IChemE Safety Centre, I'd like to welcome you to today's webinar on alarm rationalisation and lead process safety metrics. My name is Andrea Hosey and I am the IChemE rep for the Victorian member group in Australia, and I will be your chair for this evening. Before we commence the presentation, as we are hosting the event from Australia, I would like to acknowledge the traditional custodians of the country throughout Australia and recognise their continuing connection to land, waters and community. We pay our respects to them, their cultures, and to the elders, both past and present and emerging. So just a little bit of housekeeping for this evening. We do have two presenters and we will be having a Q&A at the end. So I would encourage everybody to use their chat panel to ask questions during the event, as one of our presenters is UK based and has to leave before the end of the presentation. So just to introduce our speakers for tonight, we have two online. So Garry, could you pop down the slide?
Yep.
So we have Garry Law with us. He has a wealth of experience in working in oil and gas, both onshore and offshore, for operators and in the engineering design contractors and consultants across the globe. Over the last 25 years, he has focused on process safety and design and operations, and has a particular interest in promoting inherently safer design, including learning from past incidents, which we'll see a few of tonight, and helping plant operators to develop a robust process safety management practices. He is a experienced hazard facilitator, an IChemE trainer, and he is a professional safety engineer and does a lot of volunteering with the IChemE. So I'm very thankful for that, Garry. Always a pleasure to introduce you. But it also gives me great pleasure to introduce Susanna Ganesh. She is the Deputy Director of the IChemE Safety Centre and is actually based in the UK. So thank you for getting up early today, Susanna. She has a wealth of process safety management experience, including training CEO and management level personnel of hazards and establishing process safety leadership and cultures in businesses before she joined the IChemE. And has a lot of experience implementing process safety management tools and systems, reviewing safety reports, and advising on risk reductions. There's a lot of site experience that I've cut out, but you can read on the intro for the event. But a particular passion of Susanna's is lead process safety metrics. And on that note, I'm going to hand over to Susanna to start off tonight's presentation. Thank you.
Thank you, Andrea, and thank you everyone who joined us today, because it seems that you are all interested in what you can learn and what we can share with you about alarm rationalization. I give you the intro part with the help of Garry, and then Garry will guide you through all the details and the really interesting matter of alarm rationalization. I'm pretty sure that it will be really interesting. So Garry, if we can just jumpstart the presentation, please. So before we start, I thought that it might be a good idea to share and show you our contributors, because we are really proud of our IChemE Safety Centre member companies. And you can see here, for example, the first slide on the current operating partners that we work together. As you can recognize, there are big companies, and they all are really, really willing to share their experience and their knowledge about process safety. And that is how they actually advance and also want to to contribute and share their experience, as well as the current industry partners, as you can see here on this slide. And this is important to remember, because without them, operating companies wouldn't be able to do their job in a complete way. So I think it's really, really crucial that we have all these industry partners as well to contribute. Plus, what we are also proud of, the great number of universities and regulators from all over the world as well. And you can see here the all the members, and I can see that somebody has problem with the screen, so I switch off my camera so you can see it in a larger and bigger picture. So these are our members, and what is important to us is that we work around the framework for process safety. Now, this is not a process safety management system, and it doesn't even seek to replace any. However, our member companies decided that it is really important to them that they work around the framework, and so then they established this framework for process safety. So as you can see here, there are the 6 pillars, as we call them: systems and procedures, engineering and design, assurance, knowledge and competence, human factors, and culture. And what is really crucial about it is that all of these 6 pillars are underpinned by leadership. And that is, we always highlight in every publications and every forum that we speak. And in fact, when we developed the guidance materials on lead process safety metrics, we decided that, of course, they will be around these 6 pillars. Next slide, please. So before I show you the list of metrics that were identified by the first guidance document published by the IChemE Safety Centre, I give you a reason why process safety leading metrics. Why did we do this whole project, and we are still continuously publishing on those? Because this is crucial, that we have to differentiate process safety performance from occupational personal safety. And apparently there were no consistency in how to implement and develop leading metrics in many areas, in many industries. And that's important to have consistency, because then we can talk to each other more smoothly, and then we understand each other's system. So, and there is a really extensive literature on lagging indicators or lagging metrics. However, leading metrics were not as much as published. And that's why the IChemE Safety Centre took the initiative to publish these guidance documents. Thank you. Next one. And this is why we also need to focus on the leading side of process safety, to challenge the green results, and not just be comfortable and at ease that yes, that we have reached the level of the greens in lead metrics, and then we decide this is all we have to do. No, we have to challenge the system, and also take the message when something goes right, then take it as an example and continuously working on in other areas, and see how we can improve that based on the good results. So it's not all about finding gaps and errors. It's also finding the good and finding what works really in the facility. And so these are the metrics, and you can see the color coding here. And these color codes actually associate with the 6 pillars in the framework. So we have all the elements of the framework on the left-hand side in the first column, and then the associated metrics on the right-hand side. And especially we have the alarms in different they are associated with in human factors elements. These elements actually can overlap. So some metrics can be associated or related to other areas as well, but they are, we think, the most crucial ones that they belong to. So Next one, please. And the basic guidance document that the IChemE Safety Centre published was in 2015, where these metrics were identified and then they were further described. But then we thought that there is still some detail is missing, and therefore it was a decision by the members that we need to explore and elaborate more on different lead process safety metrics identified in the guidance document. And so that we published the supplementary guidance document, the first one on pressure relief device, as you can see in the middle of this slide. And after that, we went further and identified further lead process safety metrics for permit to work systems. And then, as you can see here on this particular slide, the working group, or I mean, the ISC decided that it sets up another working group about alarm rationalization. So whether we can also figure out or develop lead process safety metrics for alarm rationalization as per the two metrics identified, as you can see in green in the text, identified in the original guidance document. And this guidance document will be published soon. I can't give you the details about the date, but you will see it on the IChemE Safety Centre's website, and we will publish it and promote it on every forum possible. And I would like to give the floor now to Garry to lead you into the details about this really interesting topic. Garry?
Can you hear me now?
Yes, we can hear you now.
Yes,
Oh, good.
now, yes.
Good. I was talking away, no one could hear me. All right. Well, I'll keep the camera off just so that the screen's as big as possible for people to see, particularly if you're on a smaller appliance. So, yeah, I was just going to say a couple of thank yous before I get into my part of the presentation. So just to thank Andrea and the JVCEC for inviting me to talk again this year. Did a talk last year, both through the Engineers Australia and IChemE platform on tank overfill, and there's a couple of overfill scenarios that I'm going to show you because they do relate back to alarms, and when alarms don't work, we can be in big problems. Also, the IChemE Safety Centre for sort of helping me to, or allowing me to help them to get the ISC guidance note put together for the alarm rationalisation over the last 18 months or so, and also to Safety Solutions because I'm sort of representing them as part of their team today. I guess one of the things I just want to talk about before we really get into the rationalisation and the alarm management stuff was just, why am I here talking today? Basically, about probably 20 years or just over 20 years ago in the late 90s, I was working on an oil refinery in the UK. So shout out to Humber Refinery, my former colleagues there, some of them still work there. We were doing various things to do with process safety management. We had a fairly major incident in 2001, and that sort of got us scratching our heads on where we could improve. And one of the big areas we looked to improve over the following 5 years was in alarm rationalisation and management and prioritisation and all the other metrics related to that. So we went on a bit of a journey in that period in the early 2000s. So with the help of like the control experts, advanced control people and the process and the panel operators, we went through the whole process of rationalisation, getting it to a point where we could be more confident that an operator could actually respond to alarms and we could take some credit for them to reduce the risk of process safety events. So that's really where my first involvement came, and since then I've worked on gas plants and advised others as well on alarm management and taught engineering design companies as well on what they need to be thinking about when they add alarms, say in a HAZOP or a P&ID review, what that actually means to the operation side of things. So we'll touch on that a bit more later on how that links into, say, layer protection analysis and other risk assessments when you talk about alarms. So hopefully my expertise in those things will come across. and teach you some things, and hopefully get some golden nuggets you can go away with today to implement on your own systems and facilities. So alarm rationalization. Susanna's already explained. This is a supplementary guidance that's going to come out later this year. And so what we were looking at as a team that was put together from various companies around the world was to come up with some metrics that were leading. So they weren't the lagging ones where you already have to have an incident or something that has to have gone wrong to give you the information. We were looking for some leading indicators before you get into problems, really, to indicate how your alarm management or how your alarm system is working. And so the whole point of the guidance note was to point out, to say, the codes and the standards that already exist, but also to bring in some metrics that might be useful if you implement them, to point where the problems might be, where the bad actors might be, to sort of do some tidy up before you get into full rationalization. So as it says here, you can use the metrics to improve your understanding of your alarms, how you handle them, how you monitor them, and how you're meeting targets. Now, I don't particularly like the word target, but we have to use it. You have to have something to aim for. But once you meet it, doesn't mean it's the end of the story. You have to keep tracking it, and you have to keep thinking, well, have I gone far enough? And are things changing now, so that I need to look at whether these targets or these limits are really working for me. Okay, so why bother managing alarms in the first place? So I'm going to give you a few incidents now of where poor alarm management has really been one of the contributing factors. Maybe not the major issue, but certainly one of the things picked up by the investigators. The other good thing, or the other thing why you should be doing alarm management, is most industry regulators, and if not all of them, will be asking you at some point what you're doing about your alarm, how do you monitor your alarms, and how do you know your system's good for managing those. So recognised and generally good engineering practice, this RAGA-GEP is sort of linked into a lot of the codes and the standards and the industry regulators guidance. To give you one example there, the HSE UK, they've got a good guidance note. It's been out for about 25 years now, called Better Alarm Handling. So you can look that up if you're in the UK, and even if you're not, it's a good place to start, but also to look at some of the other codes and standards that I'm going to show you a bit later. And I'm sure that WorkSafe here in Australia and NOPSEMA and other regulators will have similar guidance notes. So the other good reason is obviously to reduce the chance of incidents, or to at least give you a chance of reacting in the right way if they do happen. So some of those things listed at the bottom, not just safety, but also environmental issues, could be increased production or less chance of upsets due to incidents on the plant, leading to a production loss. Things around quality could be an issue, and also operations and maintenance costs could be reduced as a result of people reacting the right way to their alarms. So the first incident I wanted to talk about was Texaco, which Milford Haven, which often comes up when people talk about alarm management. This happened in the UK in 1994. As it says there, a large number of alarms made it difficult for the operator to assess what was going on. So I'll just talk you through the actual event and then come back to that alarm thing on alarms. So July 94, it said a series of events led to the accident starting on the morning of Sunday the 24th of July. It said a severe electrical storm caused plant disturbances that affected the vacuum distillation, alkylation and butamy units, as well as the fluidized catalytic cracking unit, which is called the FCC. It says the crude distillation unit that provided feed to another cracker unit was shut down as a result of a fire that occurred at that time, which was started by the lightning strike. And during the course of that morning, all the other cracker unit was shut down, but the FCC was left on. The direct cause of the explosion, so it says, however, the direct cause of the explosion that occurred some 5 hours after that first fire was a combination of failures in management, equipment and control systems during the plant upset. This led to a release of about 20 tons of flammable hydrocarbons from the outlet pipe of the flare knockout drum of the FCC unit, which was the unit that was left on. So the explosion obviously was flammable hydrocarbon liquids being continually, well, not obvious, but it was continually pumped into basically a deadhead process vessel that, due to a valve malfunction, the outlet was closed. So the only means of escape for that hydrocarbon once the pressure rose was through the pressure relief system, which wasn't designed for the amount of liquid it saw. There was an excursion above normal pressures, liquid breakthrough to the flare knockout drum, and a failure occurred at the outlet pipe. And as we said, there was the 20 tons of mixture. Ignition source was about 110 meters away. An explosion. So yeah, pretty devastating. For those that were there at the time, will remember that for the rest of their life, obviously, and anyone around that in terms of the local community who were affected. So there is actually a report available by the UK HSC on their website, so HSC.gov UK. But one of the key findings was the control panel graphics did not provide necessary overviews to allow the operators a good chance of reacting in the right way. There was lots of confusion due to the excessive number of alarms in the emergency situation, which reduced the effectiveness of the operator response. So they probably got flooded with alarms, and any alarms that they did have, they probably had so much going on at the same time, they were confused, and that led to ultimately the block-in and the failure. So that's the first one. Second one's a bit closer to home for me. When this happened, I was actually in the UK, and this is an incident that occurred in Victoria, in Melbourne, near Melbourne, SO Longford. But I was in the UK at the time it happened, but it went around the world eventually that this had happened, because a guy called Andrew Hopkins wrote his book, Lessons from Longford, and he actually came to visit our refinery a few years later after we had an incident. So it's amazing how these things eventually will get around the world. And so it's not just about safety, production, all the other things, but it's also about the knock-on effect to your business and how that affects the wider community and international recognition for the wrong reasons. So you can read Andrew's book, which is now sort of over 20 odd years old. You can read the IChemE's article where Trish Kerran from the ISC actually interviewed Andrew a couple of years ago. So that's available on the IChemE website, called The Long View of Longford. And the other thing is the Longford Royal Commission, which was the local commission that Parliament of Victoria asked for, which was published in 1999. Now, I'll just give you an overview of the actual incident itself, but as you can see here, they had 300 to 400 alarms daily. This was sort of picked up during the incident investigation, and up to 8,500 during an upset condition. And all of this was accepted as normal, and this was sort of listed in the findings of the Royal Commission. The actual incident itself was 25th of September 98. A vessel in the Longford Gas Plant 1 fractured, releasing hydrocarbon vapours and liquids. There was an explosion of fire. 2 employees died and 8 more were injured. Pumps had tripped, halting the flow of hot oil. Cold oil and condensate continued to flow, causing the temperature in the heat exchanger to drop considerably, so a cryogenic case, and failure as a result. When hot oil was reintroduced, the heat exchanger had a brittle fracture. The resulting fire burned for 2 days. Full gas supply to the state of Victoria was lost for a short time and not restored properly until about the 14th of October. That was some 20 odd days later, or around about that, 18 to 20 days later. As natural gas was used widely in most of the houses in Victoria at the time for cooking, water heating and home heating, many Victorians endured 20 days without gas, hot water and heating, hence why it's called cold. Everyone remembers this as the cold showers in Melbourne problem. So yeah, reading up that, this is a really good one to read up on. But the Royal Commission had lots of findings: isolations, dangerous vapours and materials. It was very difficult, inadequate training around operating procedures, and inadequate handover between shifts. But the one thing I picked out was the excessive alarms and warning systems that caused workers to become desensitized to possible hazardous occurrences. So they had so many alarms, they got desensitized to how many they're getting and what it actually meant to them, that they were out of control. Okay, a couple more that's probably more widely known around the world, certainly in the oil and gas industry, in more recent times. Texas City has been widely used as a case study in lots of process safety courses, including the IChemE Fundamentals course. Again, there's problems with lots of alarms either not working or giving them the wrong signals, and some of these were ignored during the incident itself. So Texas City is obviously in Texas in the US, owned by BP at the time after taking over from Amoco a few years before. So it occurred on 23rd of March 2005. Hydrocarbon vapor cloud was ignited and violently exploded at the isomerization process unit at the refinery. Hydrocarbons originated from liquid overflow from a blowdown stack following the operation of reference splitter overpressure protection. So there were 15 people killed as a result. 180 people were injured, mostly the local construction village workers who were in a meeting at the time. It was too close to the plant that blew up, and it severely damaged the refinery, as you can see here. What I'd suggest for anyone who doesn't know about this is to go onto the CSB US Chemical Safety Bureau investigation board. Their videos are brilliant for learning from, and one of the ones they've updated a few times is this one on Texas City. So if you look in the CSB videos section, there's even ones in different languages now, like Spanish and French is in there as well as English. So you can share that widely and learn from it. One of the CSB's investigations, they investigated it, they said that there was some technical failings, including the blowdown drum that was insufficiently sized, a lack of preventative maintenance on safety critical systems, but also there was inoperable alarms and level sensors, and the use of outdated technology in terms of the blowdown drum. So yeah, again, they were pointing towards either the lack of alarms or the wrong signal was given to them, or they reacted in the wrong way. Buncefield came up last year when I presented on overfill. Buncefield, UK, same year as Texas City, a bad year for process safety incidents. There's a lot of information on this one as well. I'll just go through exactly what happened. So the massive vapor cloud explosion, which measured 2.4 on the Richter scale, so huge, occurred at the Buncefield fuel depot near Hemel Hempstead in the centre of England. It's close to the M1 motorway, which is the main one of the main motorways down to London and Heathrow and those sort of places, sort of down that way. In the morning of 11th of December 2005, it was caused by an overflow from one of the storage tanks, resulted in a large release, over 300 tons of gasoline, and many other tanks and businesses were damaged nearby. There was all sorts of other things as a result, as well as the explosion. But one thing that didn't happen was there were no fatalities, and I think that was more luck than anything else, because it happened at 6 o'clock in the morning on a Sunday. But you would think any other day of the week or any other time it would have caused significant number of fatalities, particularly as a lot of the businesses and cars were crushed nearby. So one of the main things, like it mentions here, the tank level instruments and alarm trips were not working at the time. So even if they had got them, they may not have had enough time to react, or they just weren't working. And that seemed to be, from what the investigation found, that there was a concern, from contractors to site managers, but they didn't do anything about it, that these independent level flow switches weren't working, or hadn't been fitted with the right padlocks and things to make sure they were tested. Okay, the final one I'm going to go before I go back to the main crux of today is the Capeco fuel terminal, which is very similar to Buncefield, but it happened 4 years later, and almost exactly the same thing, and lessons weren't learned in between. So if you watch the CSB video on this one, I think it's called Filling Blind, then you'll be able to see what happened at Buncefield and Capeco, and hopefully learn from that, and look to improve your alarm systems as a result, and your trip systems. Okay, so I went through all those quite quickly. The next thing is a little video clip, and I'm not sure whether the sound will share with everyone, but this is from the China Syndrome. Now, the China Syndrome was a film back in the 70s, and you go, "Oh, why, Garry, you're mentioning this?" Well, it's because it sort of shows a control room situation. Yes, it might be an old control room and not look like the ones we build today, but there are actually quite a few like this around the world that still exist. So it's just to show you really how this guy Jack Lemmon, who's one of the main actors in the film, how he reacts to it, and he sort of goes around. He has to check various things. He tells the other operators to do certain things, but if he can't hear it, basically all the alarms are going off all across the panel at the top, and he can't hear himself think. And by the end of the clip, he's telling them to shut it down. So I'll quickly run this, and just to see what can happen in an emergency situation. Then I'll tell you a bit more about it. So you can see all the alarms are going off now. So if you couldn't hear that, basically everything was going wrong. An incident had just started. He was trying to instruct the operators to sort of monitor various things and do certain things to shut down safely. But he was basically saying he couldn't hear himself think, so just shut the alarm off. Just told him to shut everything down. So they weren't really reacting to the alarms anymore. They were just doing what they thought they should do to regain control. So the alarm flood, so this shows alarm flood, but it's the same in many older plants with large walls of sort of physical alarms, keys, buttons, etc., and computer screens all over the place. Obviously, it's a bit different to that nowadays with modern DCS systems. But the thing about the China syndrome, they actually, by chance, released it just 12 days before the 3 Mile Island nuclear incident that happened the same year in Pennsylvania. So maybe they had a crystal ball and they could see what was going to happen in the future. So the other thing, that's called alarm flood, but if you have too many alarms, you obviously can't see the wood for the trees, you can't focus at the right time, so you're unable to see what's important in the situation because of all the detail going on. And really the Texas City incident I showed you at the start, the last 11 minutes before the explosion, there was 275 alarms activated, which was far too many to really react properly to all of them, so they must have had to shut down or suppress quite a few of those. There were too many standing alarms, and the other thing was alarm priority. So 87% of 2,040 alarms that they had were high priority, whereas you'll see later in the metrics we're looking more like 10 to 15% or less for a sort of high or emergency type alarms. So they hadn't distinguished between safety critical and other types of alarms that are lower priority. So how did we get here? So older systems obviously have hardwired panels for alarm initiation, sort of the physical alarms you can see on the big panels, and the audible sounds. They're limited in capacity and costly, but on modern DCS SCADA systems, alarms are free, so there's no incentive to limit the number, as it says at the top there. So you can basically add as many alarms as you like, and if you've got no management of those, then you just keep adding and adding, and eventually you end up with a number that when the system goes wrong, you just get flooded with alarms and can't really react properly. There is a belief by some people that more alarms is better, so just adding more alarms will get you out of trouble, which isn't necessarily the case. There's some places where they haven't got an alarm philosophy to start with, so they're trying to do some sort of alarm rationalization, but they haven't actually got a philosophy around how they want to manage the system in the first place. That's something that needs to be in place before you get there. There's also sometimes default alarm settings, like the different percentage of ranges, and that can lead to more alarms that you don't really need, or ones that are sort of clouding your judgment. There can be inadequate MOC on alarms. So every time you do a HAZOP or a design review, you add more alarms, and there's no real management change around the alarm section of that. So that's really up for the plants and the operators and the facilities to really work out how they're going to manage that influx of alarms that comes in every time a project happens. And there's a focus on the technology. So you can do also whizzy things now on the modern DCS screens, but they don't really, for a long time, they weren't focused on the human in the loop. And that's where we're trying to get back to over the last 10 to 15 years, sort of get back to there is actually a human in that loop that needs to react to the alarm and do the right thing. So some companies don't take any credit for the human reaction to alarms because they don't think they've got enough time in an emergency situation. Other companies do. So we'll talk a bit more about that as we go on. So I'll probably skip around this one. I've talked about this one, but basically there's a common error of the belief that alarm management or alarm rationalisation is just to reduce the number of alarms. So it's actually about the quality and getting consistent, reliable alarm notification systems. Rather than just removing alarms left, right and centre. It's also to work out why they're there and that they give you a quality outcome that the person can react to. So getting a bit more into alarm management now. So when you read the codes, and I'll come back to those to show you what the codes are in a minute, and a bit more about the guidance, there's various terms you'll need to know to start with. So obviously I mentioned alarm philosophy, so you need one of those. You also need to know what your alarm priority settings are going to be, or how you're going to work out what your priorities are. And then usually you come to some sort of risk assessment to do that. And then you look at safety, environment, production loss, all those other things to sort of give you the priority of the alarm, if that's part of your sort of layer of protection philosophy. You can also look on your bow ties and other things to work out if the alarm is one of the things you need a critical response to. Or procedures that call for a reaction to an alarm. So most of the other things on here are either types of alarm or they're some of the metrics you might talk about, alarm rate. But really just get your heads around this when you're reading the codes and the standards. There's lots of definitions and there's another set of definitions in the guidance note from ISC. So just get your head around what all of these things are and what they mean in terms of your system and how many of each of these types you've got. So you also need to understand, like I said, where the alarms fit. So it's not just about the alarms, it's about the whole control loop. So the process, you'll have some sort of operating window. So it might be a window of flow or pressure or temperature or level, and you'll have upper and lower bands or somewhere where you want to try and stay. And when things start to go wrong, you'll see here, this is sort of the layers of protection you'll go through. So on this little diagram on the right hand side, you've got prevention to start with. So you'll have your own process design, inherent safety type work you've done up front before you build it. And then you'll have your process control system, which is your DCS screens and your control systems, your SCADA, etc. So it's either in the field or it's in a central control room usually. From that control system, you have a whole bunch of alarms. So you see that orange section there. You can see there is the alarm and the human intervention. So that's really the first point of call you've got to stop things going out of control or going further out of control. So you've got your prevention area, your control area. But then once someone hasn't either reacted to alarm or reacted in the wrong way, things start to escalate and go towards a bad thing happening, which is shown by the sort of explosion there. So you've got safety instrumented functions, you've got trip functions, those sort of things in place. You'll probably have a whole bunch of physical protection as well. Relief systems, rupture discs, you might have bunding if it's an environmental incident, flare systems, etc. But once it gets out the pipe or the loss of control, maybe it's a reaction that's gone run away or something, then you're into mitigation, emergency response. So you need to do some sort of assessment up front to work out if your alarms are actually part of this, the Swiss cheese and the holes lining up, and whether the critical alarms are actually something you're going to have to rely on, because there's no other way of protecting you, or there's very little after you go past the alarms. So that's one way as well to work out what your prioritization is that you put on the alarms, looking back at your HAZOP, then your LOPA, and then your bow ties and other things to work out the level of reliability you need on your alarms, and how you train your operators to react in the right way. That's probably enough on that. So we'll move to the next. So the other thing about alarm rationalization is you're trying to go from, if you remember the big panel of red when there was an incident, you're trying to go sort of from that to, from the top diagram here, down to a place where you've got only a few alarms going off, or you've used some other techniques to sort of suppress alarms so that you're focusing on the right things when an emergency happens. So it is a bit of a team effort to do that, and it can take not just months or weeks, it could take years. And it's also a constant effort to try and keep things in check, because as you modify the plant or the facility, as you add more alarms, as you take alarms out for some reason, if you're doing a rationalization, all those things need to go through management of change. It's not just a one-off project. This is sort of something that needs to be resourced for the whole life of the plant, really. So it says you can resolve bad actors. It's some potential quick wins, but then you'll get some other ones coming in, new bad actors. So you have to keep looking at those to see what's causing your issues and taking the operator's focus away from reacting in the right way when there's an upset condition. The alarm management life cycle now. So this is going more into the guidance that's out there. So the IChemE Guidance 191. So IChemE stands for the Engineering Equipment and Materials User Association, which I had to look up again to remind myself. So IChemE 191 came out many years ago. The most recent edition is 2013, I think, which is edition 3. So that's one of the things that first came up with the life cycle. And since then, the ISA guidance and the ANSI, as it mentions here, 18/2016, which is Alarm Systems of the Process Industries, that standard takes the same life cycle and sort of goes into a lot more detail around each of the sections there. You'll see it's very similar to any management system. Start with the philosophy, identification, rationalization, design, implementation, etc., operations, maintenance. And then on the side of that, you've got management of change, and you've also got a need to monitor and assess. So that's where the metrics come in. And alongside the whole of that's auditing. So you can audit your alarm systems as well, occasionally, to make sure they're all doing the right thing and the whole management system is doing what it's supposed to do. The focus of the guidance note from the ISC is just the areas in green. So the ones circled here, there's sort of 4 areas. And that's what this little diagram in the guidance says, in terms of you start with philosophy, identify your bad actors, or what alarm systems you want to review, do some rationalization, and then once you've done it, you monitor, assess how well it's gone, and then you go back into identifying another bunch of alarms that you want to look at and do the system again. So you keep going around in a bit of a loop. So yeah, I think I've given you the code. So if you look up IChemE 191 or the ISO or IEC 62682, those two will give you a lot of information on alarms that you can use, and that's also referenced from the IEC guidance. So the IChemE, it defines robust alarms as reliable during all plant modes, including normal operation and plant upsets. So even during normal operation, you need to be monitoring things, making sure they're not overloading your plant. And the operators have a high degree of confidence, and so they're not doing like some of those incidents where they just had so many alarms, they're just superfluous. They don't really think about them anymore. They're just there and they shelve them. So he's talking here about you need a monitoring system, and so that's where the metrics come in. So the IC guidance note has 3 different areas that it focuses on for the metrics: stable, unstable plant, and configuration metrics for the whole system. So we'll go into that a bit more now. So I won't probably go over why you need performance metrics again. That's really what Susanna covered at the beginning. As I mentioned before, the metrics guidance is focused on helping to do the rationalization process and probably identifying a few bad actors before that. So using these metrics will sort of lead you to where the target areas are to start with. You may still need to do full may need to do full rationalisation, or you may even have to do advanced techniques or enhanced things like flood suppression or other system modifications to make sure that in an instant the operators can still react in the right way. Probably won't go through these steps right now, but this is all in the guidance note to say what you need to do to start and get through to an action plan to address any gaps in your alarm system. Yeah, there's a lot more detail in the guidance note. So basically these 5 steps are all split down and say how you can go about using the metrics and how to identify gaps and go about your alarm rationalisation exercise. So I'm getting towards the end now. So the last few slides are around the actual metrics themselves. The stable plant metrics, there's a couple listed here. I think it's maybe 1 or 2 more actually in the guidance note. But one of the things you can measure all the time is number of alarms per operator console every 10 minutes, and sort of measure how many of those alarms on average every 10 minutes they're getting and having to react to. And really you want to try and get it down to really low numbers. As it mentions here, there's a target of approximately 1. So if you're in single digits, you're doing a good job. If it's a lot more than that, then you need to sort of look at it with quite some high priority, and you may need to go to full rationalisation if you're getting that many already in stable plant operation when everything's supposed to be in check. And the other ones here, stale alarms, so things that indicates that you've got a poor sort of operating practice and you've done poor rationalisation maybe. Number of stale alarms you're getting. When you get into unstable or plant upset type conditions, you expect there to be a lot more alarms. Again, you can measure those when you have the upsets and get an idea of some lessons learned from the incident that you can feed back into your alarm system. So there's numbers here for the number of alarms in that upset condition, and you see it's a factor of 10, maybe higher than normal operation. And the other thing you can look at is percentage of time the alarm system goes into a flood condition. And there's definitions around what flood actually means, so you can look in the guidance notes. The other one that's a good one to look at, as well as the stable and unstable, is configuration. So this is looking at the whole system and looking for bad actors, and also the distribution of the priorities of those alarms. Like we said at the start, if everything's high priority, then what does the operator do in an emergency when everything comes up at the same time? So if you look at all the priorities across the board of your alarms and which ones you think are going to come up for a particular area of the plant during an upset condition, and then just look at the percentage of each type. And it's up to you how you define high, medium and low, but there is a lot of guidance around that, again, in the MUA, ISA and the guidance we've put together. But you may, if you really way out of these sort of bands, then you probably need to go to full rationalisation. But there's things you can do around the edges in terms of these other things, chattering, fleeting alarms, things that come in and out all the time that are just causing a distraction. If you can get rid of some of those things, that helps in the emergency situations as well. And you can also have like a hit list of the top 10 alarms that go off the most often and try and get rid of some of those, so that, again, it doesn't add to the flood when things happen. So I think that's most of what I wanted to cover. So I'll just do a bit of a wrap up and then I'll hand back. So the concluding remarks. So as I mentioned sort of halfway through, when it comes to alarms, more is not always better. So when you're doing your design and management of change, just think, do you really need the alarm that you're about to add? A bit like when you do QRAs on P&IDs and you do your parts count, you can also do a count of all the alarms and work out whether you really need all of them, what they're there for. Link that back to your HAZOPs and your LOPAs and your bow ties and all the other risk assessments you do. And just make sure that you really need them before you add them. And make sure that they're actually defined properly as well, so you're actually handing over a quality product to the end user. As it says here, all must go through MOC, all changes to the alarm system. Yeah, they must meet the alarm philosophy though, so if you haven't got one, that's not good. But the other thing is to hand over the alarm philosophy to a designer or whoever's doing those changes as well. You may get some quick wins from bad actor resolution, so identifying those sort of alarms that come up the most often or are causing you most grief, and trying to deal with those first, and then see whether you need to go to a full rationalisation of all your alarms or whether there's just subsets you need to focus in on. It says here you'll get an optimal set of alarms. Keep the process operating within safe operating envelope. So you need to define what your safe operating envelope is first, and then define where the alarms are in relation to that. And hopefully then that will mean that the operators aren't overwhelmed with nuisance or confusing alarms in those sort of unstable conditions. The statement at the end is quite a good one. Alarm rationalisation can transform the operator's role. It can free them from unnecessary tasks, giving them time to focus on the process and make intelligent decisions regarding the safe operation. So that's really what the end game is, to sort of help the operator to understand when things really are going wrong and not just sort of switch off to them because there's too many going on all the time. Okay, I think I've done there, so I'll hand back to, I think it's Susanna, to do a few extra things, and then we'll back to Andrew at the end. So thanks for having me. I'll switch on my camera again once we're ready for questions. So I'll just go to the next slide. Susanna, are you ready to go?
Yep. Thank you, Garry.
No worries. I'll just bring all this up. There you go.
Yes. Thanks a lot, and thank you for going through the guidance document, and especially to present all these past incidents, which we always have to remember, because otherwise we can't improve the systems if we don't learn from these past incidents. And lead metrics may be able to help or contribute to that mission. And this is a slide that we like a lot, because you can see a couple of things about the benefits of common lead metrics. Why is it nice to have or use and apply the same sort of lead metrics? Not obligatory, obviously, and you will be able to decide if it's feasible to your operation or not. And that's why we have, as Garry pointed it out, that you will need to do a gap analysis if you want to use the guidance document. So the common lead metrics actually allow for consistent measurement and reporting that I mentioned in the beginning, that there was a lack of consistency in lead process safety metrics. So this could help. And also, if you want to benchmark between companies and industries even, then it is even possible, because you talk the same language. And maybe it is even possible good practice or best practice identification. I prefer using good practice, because that gives you motivation to reach better and better to become. And watch out for watermelons. I think by now everybody is quite familiar with the watermelon effect. That was also published in the Chemical Engineers, the IChemE magazine, TCE. That if you look at your system and everything looks green, then you may have this misconception about that your system is safe and everything goes well and everything is fine. However, when you scratch the surface or try to make a little crack on the system, then you will see that maybe not everything is so green. So just be careful of watching and listening to your results, and especially for the management. If you see that everything is green, then try and challenge those greens, as already Garry also mentioned. And of course, we always use this Goodhart's law quote: when a measure becomes a target, it ceases to be a good measure. So be careful what you measure and why do you measure those that you are measuring. It's something that indicates whether you are on the right track or you are after the numbers and the green results. Next one, please, Garry. And with that, I would like to thank Garry and everybody on the working group who contributed to develop this guidance document. It was quite a challenge, to be honest, and we have reviewed the guidance document over and over again, and we want to contribute, and we want to provide something that is at high quality, easy to implement, and practicable. So that's the essence of these guidance documents published by the ISC. As you can see the list here, and if you look again later on these slides, you will see the link to the IChemE Safety Centre It's at www.ichemE.org, and then you can guide you through the Safety Center, where you can download all the guidance materials for free. And we will be also make available the webinar all together with the members group. So that's what I wanted to say, and thank you again for coming today. And if you have any questions, then please ask Garry. And because I have to leave, but I'm really okay. I've switched on my camera. I'm very happy to take any questions by emails. You can find me everywhere, basically on LinkedIn. And if you have any questions about the IChemE Safety Center and the guidance document, I leave the heavy stuff with Garry to answer.
No worries. I know you have a busy day, so thanks so much for joining us.
Yeah, thank you, Susanna.
Thank you.
We do have actually quite a lot of questions. We're probably not going to get through them all. So I think your offer of answering by email will be, we'll take you up on that.
Okay.
So thank you very much, and good luck with the rest of your day.
Thank you.
Okay, see you. So Garry, we do have a lot of questions. We've only got about 3 or 4 minutes, so I will go to the first one and then try and pick a few. I think some that came in you've probably answered, but if you could put some answers together to email out the presentation, that would be appreciated. So the first one's probably going to be a bit of an opinion. How many metrics are reasonable to monitor for a company to get positive cultural change across process safety? That actually might have been a good one for Susanna.
Yeah, well, as Susanna mentioned at the start, we've got the metrics note from 2015. So that's the first point to look at. And it depends on the size of your facility and how many units and plants you've got, facilities. But really, if you're consistent, it allows you to benchmark between the different units. So pick a number you can actually, is sensible for you to be able to record and report up the line every month, for instance. If it's something you don't need to do every month, maybe do it every 6 months or every year. Things around integrity tend to be that sort of length of time that you need to actually see if there's any change. Whereas other things like alarms are happening all the time. So you can probably look at those monthly or even daily or weekly, depending on what the system you've got to give you the information. But be clever about it. Try and automate as much as you can. And once you've set it up, then you can have someone just clicking a button and it gives an update. But yeah, there's no right or wrong answer for that one. I think it's just really define everything and then come back to a sensible number, particularly the ones that look like they're well away from the limit or the target you're aiming for.
Okay, and I'm going to just pick one here because you showed quite a good diagram of the layers of protection. So Harry's asked, how do you define critical alarms? Is it based on risk or consequence?
Probably a bit of both. I think when I first did this on a refinery, and I think since then most companies do this, is that you actually use your risk matrix and you work out, what is the consequence, particularly for process safety events. They tend to be the high consequence stuff, low frequency. But you need to work out through your HAZOP and your LOPA if you're taking any credit for alarms. And if you are taking credit on a HAZOP, for instance, you then go to, say, a LOPA technique or a risk assessment of some sort to work out how much reliability on that alarm you've got. If you've got other things in place, it may not be so critical. If you haven't and you're relying on operator response, then it becomes critical, definitely. So there's things like that. You need the sort of process of hazard identification and risk assessment to get you to the point where you know whether it's high or not. Yeah.
Okay, I'll try and sneak another couple in that people might appreciate. So Linda's asked about the Australian standard IEC 62682, 2017, management of alarms. Do you have any comments on that document? I guess because you've recommended some other documents, as useful.
I think, I mentioned it. I didn't actually have it on the slide, but it is mentioned in the guidance. That IEC document's also there. So my comment would be, you can use that as well. That's another international standard. It's got the AS in front of it. So.
Okay, and that would be in the guidance document. Right, one last one, and then I'm going to speed finish. So somebody Joel's has seen examples of alarm rationalisation removing alarms that were determined as being useful for SIL functions. Any comments how to avoid this? Does that go back to your management of change?
I think so.
Yeah.
You don't necessarily remove alarms just because you've got trip systems to help you. You do need those signals usually for good operations as well. So yeah, you'll have different priorities maybe on like a high alarm and then a high, and the high is the one just before the trip goes or at the same time. So you still need some sort of the operator to investigate things. So you don't just take alarms out because you've got trip systems. Yep.
Okay, thanks.
Yeah.
Garry, I've pushed us right to the absolute limit. It's now 6 o'clock. So
Okay.
I'll ask you to respond to some of their questions separately, and we'll send out a note. So if you could flip to the last slide for me.
Okay.
So I would obviously like to thank yourself and Susanna for presenting tonight. And just to remind the audience that we are a member group. There are a number of member groups across Australia, and we've just got a few events coming up. Certainly, if you're interested in process safety, the event on the 10th of November in particular looks like it's got a great lineup of speakers talking about the current situation in major hazard facilities and process metrics. From the Victorian member groups as well, we are coming up to our elections, and a number of positions on the committee, including my own, will be up for election. So I'd hope just encourage members to look out for that and to volunteer and join the committee. So I think we've just run over 1 minute. So I will close the event there. Thank you again, Garry.
No worries. Thanks for having me. Thanks for everyone listening as well. See you next time.
And thank you for all your questions. The webinar will be, the recording of the webinar will be made available. And there have been some requests for the slides, Garry. So I don't know whether you make those available too.
Yeah, I can. I'll get those sent out. I'll work out the best way to do it, either through yourself or put it on my LinkedIn or something to make it shared more widely.
You're one of my favourite presenters.
Well, thank you.
So on that note, I'll close the webinar and wish everybody good night or a good morning if you're joining us from overseas, and stay safe.
Goodbye, everyone.
Bye.